A fence 24 feet tall runs parallel to a tall building at a distance of 6 feet from the building as shown in the diagram below. Find the length of the shortest ladder that will reach from the ground over the fence to the wall of the building. Write the model of the length of the ladder in terms of theta. Looking at the diagram, we're looking for the shortest length of this green segment. We also have a large right triangle here on the left formed by the fence and the ladder. Notice in relation to the angle theta, we know the opposite side has a length of 24 feet, and let's call the hypotenuse h sub 1. And now for the remaining length of the ladder, we can form a second small right triangle here. Because the distance from the fence to the building is 6 feet, we know this horizontal leg has a length of 6 feet. And because this right triangle is similar to the larger right triangle below, the corresponding angles are congruent, which means we know this angle here is also theta. And let's label the hypotenuse h sub 2. The ladder of the shortest length, L, is equal to h sub 1 plus h sub 2. And now focusing on the larger blue right triangle, in relation to angle theta, 24 is the opposite side, h sub 1 is the hypotenuse, and therefore sine theta equals 24 divided by h sub 1. And then looking at the smaller green right triangle, 6 is the adjacent side, h sub 2 is the hypotenuse, and therefore cosine theta equals 6 divided by h sub 2. And now we solve the first equation for h sub 1, the second equation for h sub 2, and then again the sum of h sub 1 and h sub 2 will give us the length of the shortest ladder. Solving the first equation for h sub 1, we begin by multiplying both sides by h sub 1. Simplifying, we have h sub 1 sine theta equals 24. Next, we divide both sides by sine theta. Simplifying, h sub 1 equals 24 divided by sine theta. Because 1 divided by sine theta equals cosecant theta, we can also express h sub 1 as 24 cosecant theta. And now for the second equation, to solve for h sub 2, we multiply both sides by h sub 2, which will clear the fraction from the equation, which gives us h sub 2 cosine theta equals 6. Next, divide both sides by cosine theta. Simplifying, we have h sub 2 equals 6 divided by cosine theta, and because 1 divided by cosine theta equals secant theta, we can also express h sub 2 as 6 secant theta. So again, the length of the shortest ladder is L equals h sub 1 plus h sub 2, which is a function of theta. Let's express L as L of theta equals, we could say 24 divided by sine theta plus 6 divided by cosine theta, or 24 cosecant theta plus 6 secant theta. And again, we know this is the length of the shortest ladder because of the two right triangles where the ladder touches the top of the fence and extends to the building. If we knew the angle theta, we could determine the length of the shortest ladder. I hope you found this helpful.